All right, guys, so this is a little bit of a more detailed question, but the idea behind it is pretty simple. So the question says the spinner below shows 10 equally sized slices. Latoya spun the dial 500 times and got the following results. Assuming that the spinner is fair, compute the theoretical probability of landing on white. From Latoya's results, complete the experimental probability of landing on white. Okay, and then you're going to answer some questions. So, experimental and theoretical probability are two different things. So theoretical probability is really just talking about an event in theory. What is your probability of something happening? And experimental probability is really talking about when you actually take the time to do it, what were your results? So this is talking about if I were to do this, and this is saying, well, I actually did it. Okay. So let's just start with what it has. So it's assuming the spinner is fair, meaning all that the spaces in the spinner are equally sized and spaced apart. Compute the theoretical probability of landing on white. So I know that there are 10 slices, so that is my total. So just as a reminder, probability is talking about a specific event out of the total number of possibilities that you have, right? So an example for this would be, for the one that we have, is that you're spinning a spinner. There are 10 total spaces. So there are 10 total things that you can land on. Okay, so that would be my denominator. And then my numerator would be the event of it, specific event of landing on white. So I will go through and I say, well, there's 1, 2, 3, 4 white spaces. So my theoretical probability is 4/10, which is also just 2/5. I don't know if they're going to make you simplify this. I think they might, but let's just go with 2/5. And that says from Latoya's result, compute the experimental probability of landing on white. So I look at the beginning of the question. It says Latoya spun the dial 500 times and got the following results. So from this, you have to look again at the definition of probability. What you're looking for, the specific event of landing on white out of the whole total. So I know Latoya has too much free time. She needs to get a hobby. Spinning a spinner 500 times. Anyway, so the total is 500, right? So I'm going to put that at the bottom. So this is my denominator. And then it says the probability of landing on white. Well, I have 177 white. Okay. And it does give you this calculator on their question. So I'm just going to put it on my Desmos calculator and put it in. So notice that it says round your answers to the nearest thousandth. So don't forget that. So my thousandths place for 177 over 500 is, well, my answer is 0.354, and I have tenths, hundredths, thousandths, so it's already in the thousandths. So I'm just going to put in 0.354. I'm also just really quickly going to go and put 2/5 in. I knew it was 0.4, but that's not the point. I think it does want all of your answers in decimal. So if it doesn't let you put a fraction, it'll let you know. Just know that you can put that in your calculator right there, and it'll tell you what your answer is. So 0.4. Okay. So assuming that the spinner is fair, choose the statement below that is true. The larger the number of spins, the greater the likelihood that the experimental probability will be closer to the theoretical probability. The experimental probability will never be close to the theoretical probability, no matter the number of spins. And then the smaller the number of spins, the greater likelihood that the experimental probability will be close to the theoretical probability. So what I want you guys to know from this is if you spin a spinner 10 times, you don't have a very high likelihood of getting 4 out of 10 times. Like it's gonna be off. Most of the times, the closer you get to 100 events, the more. So like if Latoya stopped at 100 spins, she would probably, for the most part, pretty much have the same answer. So if you round 0.354 to the same 10th place, this is essentially the same number. So it's close. It's not quite there, but it is close. So what I want you to understand is that when you actually go and do an event and do the experimental probability, it's in real life. It's going to take some time for the two to match up or to be close. So when I look at these answers, I need you guys to know the experimental probability will never be close to the theoretical probability, no matter the number of spins. This is not true. I'm telling you, if you did this and you had time on your hands to do 500 spins on a spinner, it would become close. The more you do, the closer it becomes. And it says the smaller number of spins. So if you do less spins, the greater likelihood that the experimental probability will be close to the theoretical probability. That is not true. The smaller number of spins you have, the greater likelihood that it's going to be farther away. Okay, so essentially, this is the only correct answer. I think it might give you the same 3 or close to it when you do the question every time. There might be a little bit of off wording, but as long as you know that the more spins there are, the greater likelihood that these two will be close that is the truth. That is a true statement. Okay, so as long as you're looking for that statement, you should be fine. I know someone's going to be very confused about this. That is okay. Just come and talk to me, and don't forget you can use your calculator. I do not expect you to do this in your head. And if you guys have any more questions, just let me know. Good luck, guys.